up to student to do, and that'll dictate how I go about doing this. Like I said, I don't want to keep you here waiting, and I'll try and answer questions in between. Okay, so I've got somebody else on already. I did figure out how to see who it was. Or not. Thought it would tell. Oh no, I'm the only guy on here right now. Okay, so let's get started then. Basically, yeah, we've got some people on here today. Okay, so I will, for those of you that are watching, I'm going to put on Edmodo an assignment today. You have to do the assignment, and you can email it to me tomorrow morning to get it in. Okay, and the same goes for you guys. If you're not in school tomorrow, email me the assignment. That's fine. If I know that two of the girls put them on, they took pictures and sent them. It works, preferably a PDF if that's possible. I don't know if you can, because then if it's to my email, I can print it off at the school here. Okay. All right. So let's get started. Questions today that you want to. Let's make sure that we're using this time this morning to go through as much as we can. Amarin, go ahead.
Page 184, 8B.
8B?
Yeah.
Is that the one you just asked me?
Well, yeah, I just don't know what, like, I know 18 is not a perfect square root, and then you said something like, what's the perfect square root that goes into it, and how many times?
Okay, solve each of the following by completing the square. Okay, so this actually, okay, that changes things a little bit as to what you asked me earlier. Okay, now I can divide everything by 2 to start with.
Mm-hmm.
All right, so I'm beginning like this. I have 2x squared. What is it, minus 10x?
Yeah.
Plus 14?
Yeah, and it's 20x, sorry.
Plus 20x. Okay, so I've got 20x like this equals 0. All right, so now what I can do is I can divide, because the equals is there, I can divide by 2. All right, and I can divide everything by 2 and get rid of it. If I was factoring, I have to leave it there. So if there's no equals, I leave it, but if there's an equals, I can divide it all out. So I've got x squared minus 10x adds 7 equals 0, right? Okay, now to complete the square, you've got your brackets, plus a blank, add 7, subtract a blank. Now, the book shows you to work on both sides of the equal sign, and that's fine too, but we learned it this way, so let's keep it consistent. Let's go as if on the completing the square as if I don't have it on both sides. Okay, so what goes into my blank here?
5 squared.
5 squared. Okay, so that's half that term, half of 10 squared, right? So now I've got x, so x minus 5 squared, subtract 18 equals 0. Okay, I understand your question now.
Mm-hmm.
All right, so now I put the 18 on that side. So I have that, right? Okay, now how do I get rid of the squared value? Say it again. Square root. So I'm going to square root both sides, right? So that leaves me at x minus 5 here, and over here I have plus minus the square root of 18. Okay, now the square root of 18 is fine. There's nothing wrong with the square root of 18. However, and like I said, our next section is going into radicals, so let's practice what we're going to be doing, and that is there a perfect square value that does go into 18? Quickly go through your first, yeah, right? So again, I mentioned this to you last year. We want to know those numbers fairly quickly. So you want to know 1, 4, right? 9, 16, 25. You want to know those just so that to make this go as fast as we can. So that's right. So I've got x minus 5 is equal to plus minus. What is the square root of 9?
You do 2 and then the square root of 9.
That's right. So
I have that.
That's okay, right? So we put the whole number first and then the radical. So this is the square root of 9. Square root of 9 times root 2 is root 18, right? And the square root of 9 is 3. Okay? And then what's my last step here? Add 5. So I go 5 plus minus 3 square root 2, and there's my 2 roots. And I leave it like that. It's done. Okay, there's no way to make that smaller. Again, if I was to do this question and graph it, I would get 5 plus 3 square root 2 as a decimal, and then 5 subtract 3 square root 2 as a decimal as well. So that would give you your 2 roots. Okay, so far?
Mhm.
All right. Any questions about completing the square? Okay. All right. Another question here.
Could you do 6 on 184?
Sure. Okay, one side of an envelope is 3 inches longer than the other side. The area of the envelope is 108 inches squared. Determine the dimensions of the envelope. Okay, so I'm going to draw myself an envelope here. I'm going to make one side X. What does that make the other side?
X plus 3.
X add 3 because it's 3 inches longer, right? And how do I find the area of it?
Like length times width, so x times x plus 3.
Very good. Just like that, right? Okay. Now, because I'm using quadratics, I always want to get it equal to 0. Okay. So I'm going to first of all distribute. Right? And then how do I get it equal to 0?
You have to like add or subtract 100.
Subtract 108. Okay.
Oh, okay, that makes sense now. I was just getting confused with the area thing, yeah, but that makes sense.
Okay. And then we check to see if that's factorable. So looking into it, all right, 36 and 3, is that right? 36 times 3 give me 108? I think so. So watch this, guys and gals.
Yeah.
So I have 36 times 3, right? Okay, so clearly I can't get 3 out of that. So I'm going to break it down a little bit more. Let's make this 6, 6, and 3. Okay, so 18 and 6, that still doesn't work. So this is what we call prime factorization. Keep coming down. Okay, now I'm going to look at these numbers. I'm going to see if I can jumble them together to make something add to give me 3. All right, and these are all multiplies. So that's 2 times 3 times 2 times 3 times 3 gives me what I need, right? So 2 times 2 is 12. So 4, sorry, a little ahead of myself here. But what is this? When I multiply these together, what do I get? 12. And when I multiply these together, what do I get? 9. Can I make 3 out of that? So if this is okay, so what do I need? I need a plus 3. So which one has to be positive?
The 6. Not the 6, the bigger number.
The larger number?
Which is 12.
12, that's right. And then this would be 9, right? Okay, so this is a different way of doing it. Rather than using my calculator and punching it in all the way through, which I can do, okay, I'm going to take 12 and I'm going to break it down to its prime factors and multiply them to see if I can get a number that works. So I did. So in this case, what does x equal?
Negative 12 and 9.
Negative 12 and 9. And can the distance or length be a negative number?
No.
No. So just take a look at what I just did there. I crossed that out and I made that what we call an extraneous root. So I'm showing you that it's a possibility, but it doesn't work. All right, so it's all part of the solution. We do a lot of this in grade 12. So we have to, begin to start knocking off answers that we get that don't work, okay? So the answer to this question, of course, is 9. So therefore, x equals 9 and 12. Okay? Yeah.
Could you do completing the square? Would it work too? Like same.
For this guy?
Yeah.
Yeah. You can always use completing the square. The only thing is, you know what? Where I try not to complete the square is when that value is an odd number. Because when I complete the square, I have to divide by 2, right? And then square. So it's going to end up giving me a fraction. So when this is an odd number, I try not to use completing the square. But you can use it for every single question and get an answer. All right? Okay?
I guess I have another question.
Yeah.
On 184, 7C.
Oh, you know what I'm going to start doing? Okay. 184, 7C. Okay, we'll start doing that so I get used to it next week. Okay. That's x minus 12 squared equals 80?
Yeah.
Okay. So exact values means that when I end up taking square roots of values, I don't want to have decimals. So I leave them as rooted values. Okay, so I'm going to take the square root of both sides here. Okay, so that gives me the square root of 80, right? And again, I got to put my plus minus in there. So I got the square root of 80. Okay? Again, 80 is not a perfect square, so I want to break it down.
10 goes in there.
10 does go in there, and so 10 times 8, right?
Yeah. So
But
10 goes
are either one of those a perfect square? No. Okay, so watch this though, Amarin. 5, 2, and 8. What's 8 times 2? 16. Is 16 a perfect square?
Yeah.
Yeah. So I'm going to go like this. Root 16 times root 5. And again, I use that prime factorization, right? You can use your calculator and find out. So what I would do is I would go, okay, I would check. Okay, 1, obviously, no. 4, the perfect square, 4 goes into it. 9, 16 goes into it, 25 doesn't, so I would just check my values, okay? So now what do I have? X minus 12 is equal to plus minus 4 square root 5, right? So far, you follow that or not? For me?
Yeah.
Okay, so the square root of 16 is 4, I just write it down as a whole number instead. All right, and then what do I have to do to finish the question? Add 12 to it. So my answer then is x equals 12 plus minus 4 root 5, like that. Okay? So far, so good? Okay. Any work here? Anybody watching, if you have any questions, just type it into your comments and I'll have a look at it. The review seems fairly straightforward, doesn't it?
Mm-hmm.
Any other questions in here that you want to look at? Any methods you want to see again that you're still unsure about?
Maybe one of the factoring ones where you have to substitute it in, like just another example
Sure.
on those.
Yep. Okay, well, I'm going to use the one that we worked on yesterday just because it's easiest. So this is page 183, and it's question 4B. Okay, so the question is x minus 6 squared plus 10 times x minus 6
Plus 9.
plus 9?
Yes.
Okay. All right, so I can factor it this way, but I find it difficult to factor it in the form that it's in right now. So what I'm gonna do is I'm gonna change this, and I'm gonna say, okay, I'm gonna let A equal x minus 6. So now I put it in this form, a squared plus 10a add 9. Okay, so it looks a little bit cleaner than what it did before, right? So I gotta factor it, so 2 sets of brackets. What are my factors of a squared?
1 and 9.
Okay,
Oh,
I'll put-
A, sorry.
yeah, that's all right. And then A and A, right? So I have that there. Okay. And then I've already said A is equal to x minus 6, so I substitute that back in. So x minus 6 plus 1, x minus 6, add 9. Okay? Any questions about it? You okay?
Yeah.
Yeah? All right, so then what we're gonna do next then is let's just get rid of those initial inside brackets, because minus 6 and 1, that's x minus 5. And minus 6 add 9 is x add 3. There it is. That's as factored down as I can make that.
Do you put the roots at the bottom, or do you have to put x equals 5, x equals
Okay, that's a great question. If there is no equals to here,
Then you just,
this is your answer. All right? Now you have to be aware of that because a number of you have done that on that assignment. You're looking, or sorry, on one of the last tests. Okay? If I have an equals to, I am looking for an answer, a solution. Okay? In which I have to find x equals. If I'm just factoring, this is my final solution right here. Okay? And all it is the equals to 0 or equals to at any point. If it's not there, then you just factor it. Okay? All right. Any other questions here? Page 179 and 180 have a lot of the word problems. So 6, 7, 8, and 9 there. Those are more of the types of questions that you want to be aware of in this class. We don't do many word problems in the applied that are based on these and having to set them up. Okay, in applied, we would set them up a little different. We would write out lists, X and Y lists, tables, and then solve them. In this one, we want to do equations. Okay, so let's just have a quick look at number 6 then. So page 179, number 6. All right. It says TJ has a photo that measures 10 by 15. He wants to fix it into a mat so that there's a border uniform around the photo. The mat and photo will have an area of 500 centimeters squared. What should the width of the mat be? Okay. So this is identical to the question that we looked at yesterday. I think it was yesterday we did this, did we not?
Yeah.
Okay. So the photo is 6 by 15, right? And this is X, and this is X, and this is X, and this is X. Okay.
10 by 15.
Sorry, say that again.
It's 10 by 15.
10 by 15, thanks. 10 by 15, okay. So at this point here, what is this length on the outside from here to here? What is the length from here to right here?
10 plus 2x.
10 plus 2x. And what is the length or the width from there to there? 15 plus 2x. Okay, so how would I find the area of that mat then? Just in words, how would I find the area of that mat? Okay, so that would give me the outside area, right? But the actual mat is this X area here. How would I find the?
Outside minus there.
Right, I take the area of the outside, so I've got the area of the outside minus the area of the inside. And that would give me my area of my mat. Just like that, right? Okay, so then it gives us the area. The mat and photo will have an area of 500 centimeters squared. What should the width of the mat be? Okay. So TJ has a photo measures 10 by 15. He wants to fix a mat to it, or fix it to a mat, so that there's a border uniform with the width around the photo. The mat and photo will have an area of 500 centimeters squared. What should the width of the mat be? Are we doing this right?
So,
What do we do?
We know that the outside mat's gonna equal 350 liters.
No, here's, okay. All right, the photo has an area of what? Let's start with that. Photo has an area of what?
150.
150. Is it centimeters?
Centimeters squared.
Centimeters squared, right? Okay, so I'm going to go back to here. I'm going to erase this for a second because I don't think we've done this the way we did the other question. I think this is how it differs. It says that the area of the mat and the photo make 502. So the area of the mat is the area of the mat plus the area of the photo. Would you not agree with me?
Yes.
Yeah? So then I have 502.
Just 500.
Or is it 500? Oh, I keep thinking 2. Random number. Okay, so 500 is equal to the area of the mat, which is 10 plus 2x times 15 plus 2x, and I'm going to add that to 150. So the mat itself has an area of what? 350. So I go 350 is equal to, I'm going to FOIL that out. That's 150 plus, what is that? 20 and 30, so 50x. Is that right? 2x times 15 is 30. 2x times 10 is 20. 20 and 30 make 50. Yeah? Okay, and then add 4x squared. All right, so what's the first thing that we got taught to do when it comes to quadratics?
Greatest common factor.
Greatest common factor would be 1. But what's the first thing I got to do before I get there?
Get that
Make it
negative.
equal to 0.
Yeah, I have to get it equals to 0. That's right. Everybody got that. Okay, so that's going to give me 4x squared plus 50x minus 200. Agreed? I subtracted 350 from both sides. All right, what's my greatest common factor here? 2. 2. So that leaves me with 2x squared plus 25x minus 100. Like that. Okay. Now I pick my favorite method to solve this question. Okay, go ahead.
We don't have to have that too. Would you rather-
No, because of the 0, because of the equals to 0, I can divide it completely out. If I was factoring, I have to leave it.
Okay.
So I'm gonna try, my favorite is factoring. So I've got minus 200, because I take 2 times negative 100. My sum has to be 25. And what are the factors then? Okay, so I need the factors of 200. So just gonna do this. I'm gonna split this for a second, just so I can do some factor work. I got 50 and 4, right? That gives me 200. But I can't get that to 25. So I'm gonna take that down. I'm gonna go 25 and 2 and 2 and 2. So that's 25 times 8. That's not getting me there. So let's do this now. 5, 5, 2, 2, and 2. Okay. I still can't get it. Because this would give me 20 right here and 10. That's not going to work. 5 times. Oh no, we got her. Here it is here. What does this amount to? No, that's 40, isn't it? It's not. It's thinking that's 30. It's not. I don't see this being as factorable. Okay? So what are my alternatives if I can't factor then? Quadratic formula or graphing. Okay, so how about you graph this then? So let's graph that then. And see if we can find our zeros. I'm going to try and graph it on here. I don't know if this thing did not like me yesterday. Okay. So what would the equation be? So I've got y equals, is it 2x squared?
Yeah.
And
25x.
plus 25x?
Yep. And then minus 100.
Okay,
Our
so I've
roots
got,
are wonky numbers.
yeah, they will be. Just trying to figure out where we gotta go. So minus 200. There we go. Ooh. Okay, so my grid range, change this. Minus 50, let's say. Go right. 25. Bottom minus 200. Okay. So there's what my graph looks like right there, right? And I need these values, but again, I am talking about a distance or a length, right? So can I even use this negative one that I have right here?
Nope.
So I've got negative 15.69 is what it says here, right? But that's no good to me, is it? So then what is the only possible answer I can get out of this? That's this guy right here.
3.187.
You had 3.187?
Yeah.
Yeah, I have 3.19 here. So let's go back to here. So then my x is 3.187. Okay. So then that means that the length would be 10 plus 2 times 3.187. And then my width would be 15 plus 2 times 3.187. All right, so let's calculate that. I just want to see what those lengths and widths are.
16.374.
16.374.
And then 21.374.
21 point what, sir?
The same decimals.
374.
Yep.
Okay, multiply those together and what do I get?
350.
350?
Yeah.
Perfect, we got it right. Okay. So that question was a little bit different than the other one we did. The other one we did, we subtracted, right, to get the math width. This one we had to add the two together to get the 500. Okay? We all right? Not sure why it doesn't list this, but anyways. Okay. No other questions? All right, so those of you, there's two of you listening. I'm not sure who you are. Anyways, I will put a assignment on Edmodo this morning. So you want to get that off Edmodo, and if you want to email it to me when you're done, that would be ideal. I would like to get it in by 9 tomorrow morning. Okay. There will be no test on this. That's the only assignment, and that'll be the last assignment we have going into this 3-week break we have here. Okay. So we'll be working on 5 and 6 through the break. All right. Okay, if you just send me a comment as to how this all worked, whether you could hear, whether you could see, whatever. So I'm not sure whoever you are, if you don't mind going on there, please, and comment. All right. You guys are all good?
Yep.
Okay.